Here we have 2 points. Point A is at 1, 2, and point B is at 3, 6. And we've got this line segment connecting the 2 points. And I want to find out everything I can about this line and all the things associated with it. Let's find the position of the midpoint first. The midpoint being halfway along this line. Well, quite a nice method to do this is to take the 2 coordinates. We've got 3, 6. We got 1, 2. And we're going to add the ordinates together and then divide it by 2 to get the mean average of these points. And that'll tell us where the middle is. So if I add these 2 together, I've got 3 plus the 1, that makes 4. And I've got the 6 plus the 2 to get 8. And now I half these values to work out where the midpoint is, because it's the mean average of these 2 points. So you half it. So the midpoint is at 2, 4. Does that agree with what we got here? So we're 1 here and we're 3 there. Halfway between 1 and 3 is 2. And we're 2 here for the y ordinate and 6 there. And halfway between 2 and 6 is 4. I'm happy with that. Well, what if B was the midpoint of a longer line? Where would the end of that line be? Well, if B is the midpoint, and it's gone 2 across and 4 up, we'd need to go another 2 across and then another 4 up. So it would be all the way up there. Let's move that down a bit so you can see. So where is that point there? Well, we can track this, can't we? So it goes 2 across and 4 up to get to the midpoint. So we've gone from 1 to 3, that's 2. So we need another 2 in the x values. So that point there is going to be 5. We go from 2 to 6, that's plus 4, another plus 4, so the y value of that point there is going to be 10. What else can we discover from this line segment? Well, we could look at the length of this line using Pythagoras. If we were to draw a vertical line down here to show the distance between these 2 points vertically, and a horizontal line across here to do the same thing, we'd get a right angle triangle. And we can use Pythagoras theorem to calculate the length of this line AB. So we know the difference between 6 and 2 is 4, and the difference between 1 and 3 is 2. So we can use Pythagoras theorem to work out the length of the line AB. So length AB equals, well, we take the square of 2 plus the square of 4, and then we square root that to just get the length of AB. So here we have 4 plus 16, that's 20. The square root of 20, which is square root of 4 times the square root of 5, so we get 2 root 5. Oops. 2 root 5 as our final answer there in surd form. What else can we do for this line? Well, how about the gradient, how steep it is? We've already got the difference in y values there and the difference in x values, so we can calculate the gradient of this line. Let's do it here. So the gradient of AB equals the change in the y values that we've got here. So 6 take away 2, we already know that's 4. And then we're going to divide that by the change in x values. So we've gone from 3 to 1. So 6 minus 2 is 4, and 3 take away 1 is 2, and 4 over 2 means that our gradient is 2. 4 divided by 2 is 2, and that makes sense. For every 1 unit we go across, we go 2 units up. Okay, what else can we work out here? How about the equation of this line? And that would give us any point on the line. That's interesting. So let's call the general point x, y. So some point on this line, we'll say it's got an x value and it's got a y value. Now we already know how to work out the gradient, and the letter that we use to describe a gradient is the letter m. And you might have seen this before, that we use y equals mx plus c. where m is the gradient and c is the y-intercept. If we use this form, we already know that the gradient m is equal to the difference in y over the difference in x. So if we take the general point y, take away a specific point, I'm going to use a because it's got nicer numbers, and we'll call that y1. And then we divide that by, we take the general point value x, and then we'll take away a specific value, which I'm going to use this one down here. We've got this equation here, and actually rearranging this is really useful. So we'll have, let's just move that up a bit so we've got some more space. We'll have, I'll do it down here, y minus y1 equals m brackets x minus x1, and that's just a rearrangement of this by bringing the division here to a multiplication on the left hand side there. Now we can use this to work out the equation of this line. Like I said, I'm going to use point A because it's got nicer numbers. So general point y minus 2, because that's the y value of this point, equals the gradient that I worked out earlier, 2 brackets x, the general point, minus x1, which is 1. And if I want to tidy this up to make it look better, I've got y minus 2 equals 2x minus 2, so y equals 2x is the equation of this line, because I've got a minus 2 there, add 2 to both sides, I get y equals 2x. And that's the equation of this line here, AB. Is there anything else I can do? Well, how about we look at a line that's perpendicular to this line. So instead of 1 across and 2 up, it's going to come straight through like this. Doesn't matter where I draw it on the line. What I'm looking for is a right angle at the point where they intersect. How can I find the gradient of this line? Well, if we just look at it for a moment, the y, the change in y, it goes down 1 there. So we're going down, so I'm going to call that -1, and it's going across here, it's going across 2. So the gradient of this line, that's perpendicular to our original line, the gradient equals the change in y, which in this case is -1, over the change in x, which in this case is 2. So the gradient of this blue line here, that's perpendicular to the line AB, is -1/2. There's a really interesting result here, that if you've got two lines that are perpendicular, the product of the two gradients equals -1. Let's check that with these two here. So this black line, AB, the gradient is 2. And the blue line, the gradient is -1/2. So the product of these two is -2 over 2, which is -1. And that's true for all lines where the gradients are perpendicular to each other.